to solve many type of combination problem, including this type of problem. That is, a party of 9 persons is to travel in 2 vehicles, one of which will not hold more than 7 and other not more than 4. In how many ways they can travel? To solve this type of problem, we need the knowledge of combination. In this video, I will discuss about some formula to solve this type of many problems. The discussion about the solution of this problem is in the later part of this video. I hope after watching this video, you can easily solve this type of many problem, including this problem. Now, let's start the main discussion with a question. In how many ways the letters of the word professor taking 4 letters at a time can be selected? Solution. The total letters in the word professor is 9, where 3 set of pair letters, that is 2S, 2R and 2O, and the other letters, that is P, F and E, are different. Here 4 letters can be selected from the 9 letters in following way. So in this case, we can choose the pair letter or we can choose the individual different letter. The first way, that is, we can select 2 pair, that is, we have to fill the 4 position. If we select 2 pair, these 2 pair will fill up the 4 position. In the second case, we can select 1 pair and 2 others letter. If we select 1 pair, that pair will occupy the 2 position and the remaining 2 position we have to fill up with other letters. And case number 3, where all letters are different. Here, if we find the combination value for the first case, that is 2 pair, so we have 3 pair, that is 2S, 2R and 2O. From these 3 pair, we have to select 2 pair, that is select 2 pair from 3 pair. In the second case, the combination will be, we have to select 1 pair from 3 pair and select other 2 from the other letter. That is, in that case, all letters should be different. That is, first we have to select 1 pair. When we select, suppose we select double S. Other than this double S, there are other 2 pairs, that is double R and double O, and P, F, E. These are the different letters. So if we want to select 2 from the others letter, where all the letters are different, that case we have to exclude 1 R and 1 O. That case P, F, E and 1 R and 1 O. From these 5 letters, we have to select 2 letters. And in the case 3, that is when all the letters are different, in that case, if we want to make all the letters different, here we have to remove 1 S, 1 R and 1 O. In that case, the total number of letters will be 6, that is P, R, O, F, E, S. From these 6 letters, we have to select 4 letters. So in the first case, the result will be, we have to select 2 pair from 3 pair, that is C32, which is equal to 3. And in the second case, first we have to select 1 pair from 3, that is C31, and the others letter will be 5, and from 5 we have to select 2, that is C52. And here there is the AND, so according to AND rules, we have to multiply these 2 values, that is C31, the value is 3, and C52, the value is 10. So 3 into 10, which is equal to 30. And the last case, we have to select 4 letters from 6 letters. That's why the result will be C64, which is equal to 15. And total result will be the sum of these 3 cases, that is case 1, case 2 and case 3. If we sum these 3, that is 3 plus 30 plus 15, which is equal to 48. This is our result. So we have 48 ways to select 4 letters at a time from the word professor. Let's solve another problem. A cricket team of 11 players is to be formed from two groups of 6 and 8 players so that at least 4 players from the group of 6 players will be included in that team. The solution is, here 11 players can be selected from two groups in the following way. That is, here the 6 player group, this one is the 8 player group. The condition is at least 4 players from the group of 6 players. So the 4 player from the group of 6 player, and we have to select 11. So rest 7 we have to select from the group of 8. And the second case, that is, if we select the 5 player from the 6 player group, we have to select 6 player from 8 player groups. And the case 3, that is, if we select 6 player from the 6 player group, if we select all the players from 6 player group, that case we have to select 5 player from the 8 player group. There is no other option because we cannot select more than 6 player from these 6 player groups. So these three, case 1, case 2 and case 3 are the way of selection of 11 pair from these two groups. So let's see what will be our result. So from 6, if we choose 4, that case the result will be C6 4. And if we select 7 from 8, that will be C8 7. We have to choose 4 player and 7 player. So according to AND rules, we have to multiply these two values. C6 4 is 15 and C8 7 is 8. If we multiply these two, the value will be 120. For the second case, the value will be C6 5. That is, we have to choose 5 from 6, and C8 6. That is, we have to select 6 from this 8 player. And if we multiply these two, the value will be 168. In the last case, we have to select 6, all 6 player from the 6 player group. That's why C6 6. And we have to select 5 player from the 8 player group, that is C8 5, which is equal to 1 into 56, which is equal to 56. And the result will be the sum of these three cases, that is 120 plus 168 plus 56, which is equal to 344. This is our required result. So the way of selection is 344. Let's solve another problem. Out of 14 players, 5 players are bowler, 2 wicket keeper. In how many ways a cricket team of 11 players can be formed so that the team will consist of at least 1 wicket keeper and 3 bowlers? The condition is we have to select at least 1 wicket keeper and 3 bowlers. The solution, here in 14 players there are 3 groups. 5 are bowlers, 2 are wicket keeper, 5 plus 2 is 7. Other than this 7, the 7 players are batsmen or other category. Here 11 players can be selected from 3 groups of players in the following ways. That is case 1. Here first group is group of wicket keeper, second group of bowler, and third group the other 7. The condition is at least 1 wicket keeper we have to select and 3 bowler. So the case 1 is 1 wicket keeper, 3 bowler, that is 3 plus 1 4. We have to form a 11 player team. So if we subtract this 3 plus 1 4 from 11, the result will be 7. So we have to select other 7 players. And the case 2, that is 1 wicket keeper, 4 bowler, then 6 from other group. Or case 3, that is 1 wicket keeper, 5 bowler and 5 other players. Here total number of wicket keeper is 2. So we can select 2 wicket keeper also. So 2 wicket keeper, 3 bowler, 6 others. 2 wicket keeper, 4 bowler and 5 others. And 2 wicket keeper, 5 bowler and 4 others. In this 6 way, we can form a 11 player team from these 14 players. So let's find the result for the first case. That is select 1 from 2, that is C21, select 3 from 5, that is C53, and select 7 from 7, so C77. The result is 20. For the second case, that is select 1 from 2, that is C21, select 4 from 5, that is C54, and select 6 from 7, that is C76. So the value is 70. For third case, that is C21 and C55 and C75, which is equal to 42. The next case, that is, we have select 2 from 2, that is C22, and select 3 from 5, that is C53, and select 6 from 7, that is C76, which is equal to 70. The next case, that is C22 and C54 and C75, which is equal to 105. And the last case, C22, C55 and C74, which is equal to 35. If we take sum of all the case, that will be the total result. That is 20 plus 70 plus 42 plus 70 plus 105 plus 35, which is equal to 342. This is the required result. Here we use the multiplication because we have to construct the team of 11 players. So this 1 and this 3 and this 7 will make the 11 player. That's why according to AND rules, we have to multiply all the combination value get from this first group into second group into third group. Now let's see one exceptional example. That is, a party of 9 persons is to travel in 2 vehicles, one of which not hold more than 7 and the other not more than 4. In how many ways can they travel? The solution. Here, 9 persons can be travel in the following ways. That is, here, this one is the case number 1, this one is the case number 2, this one is the case number 3, and this one is for first vehicle, this one is for second vehicles. And the first way of selection is, first select 7 from 9. Select 2 persons from rest of 2. That is, in this case, for the first vehicles, select 7 from this 9 person, and rest 2 is selected for the second vehicles. In this case, for the second vehicles, we have to select 2 out of 2. After selecting the 7 from 9, there is 2 persons left. For the second vehicle, that's why we have to select 2 from these 2. That is, in this case, the result will be C97. That is, select this 7 from this 9 and select this 2 from rest of 2. That is C22. According to the AND rules, these 2 will be multiplied. That is 36 into 1, which is equal to 36. In this case 2, for the first vehicle, select 6 from this 9 person, and the rest 3 is selected for the second vehicles. In this case, for the second vehicle, we have to select 3 out of 3. That is, the result will be C96. That is, select 6 from 9 and select 3 from rest 3 for the second vehicles. Similarly, for the third case, select 5 from 9 and select 4 out of 4 for the second vehicles. In this case, the result will be C95 into C44. That is 126 into 1, which is equal to 126. The result will be the sum of the result of these 3 cases. That is 36 plus 84 plus 126, which is equal to 246. Again, in another way, we can solve this problem. That is, in this case, first we select for the first vehicles and the rest of person for the second vehicles. If we first select for the second vehicles and rest of person for first vehicle, the result will be same. In that case, first we have to select this 2 from 9, that is C92, and select the rest 7 from 7, that is C92 into C77. We know the value of C77 is equal to 1. That's why the value will be C92 into C77, which is equal to again C92. Similarly, it will be C93 and rest 6 from 6, that is C66. Again, in that case, the result will be C93. And for the third case, the result will be C94. For the complementary combination, we all know the value of C97 and value of C92 are equal. And the value of C96 and the value of C93 are equal. And the value of C95 and the value of C94 are equal. So, if we select for the second vehicles first, that case the result will be also 246. In this way, we solve this type of problem.